All right, you guys, I promised something new, and you will indeed be learning all about New Technology File System, or commonly referred to NTFS. Why don't we just jump right in? That's the way to do it. So NTFS, right, stands for NT File System or New Technology File System. But anyway, it's the file system that Windows NTOS uses, that's the operating system, for storing and retrieving files on hard disk drives, HDDs, and solid-state drives, or SSDs. So NTFS is the Windows NT equivalent of the Windows 95 File Allocation Table, FAT or FAT, and OS/2 High Performance File System, or HPFS. But you got to understand, NTFS offers several improvements over FAT and HPFS in terms of performance, extendability, and security. Very important. So Computer's OS creates and maintains a file system on a storage drive or device. The file system essentially organizes the data into files. So it controls how data files are named, stored, retrieved, and updated, as well as what other information can be associated with those files. So, for example, data on file ownership and user permissions. NTFS is just one type of file system. File systems are generally differentiated by the OS and the type of drive that they're being associated with. Now, these days, there's also a distributed file system, or DFS, where files are stored across multiple servers, but is accessed and handled just as if it were stored locally. A DFS actually enables multiple users to easily share data and files on a network, and it provides redundancy as well. Now, Microsoft Windows and some removable storage devices use NTFS to organize, name, and store files. NTFS is an option for formatting SSDs, where its speed is particularly useful. Now, HDDs, USBs, and micro SD cards that are used with Windows also will benefit from NTFS. So depending on the storage capacity of the device, the OS used, and the type of drive, a different file system might just be preferable, such as FAT32 or extended FAT. You might see it as exFAT. So each file system has benefits and some drawbacks. For example, security and permissions are way more advanced with NTFS and exFAT and FAT32. On the other hand, FAT32 and exFAT work much better with non-Windows OSs such as Mac and Linux. Now, just to be clear, all Microsoft OSs from Windows XP on use NTFS version 3.1 as their main file system. But NTFS is also used on external drives because it has the capacity those drives need, supporting large files and partition sizes. NTFS can support up to 8 petabytes of volumes and files on Windows Server 2019 and Windows 10, according to Microsoft. But the theoretical limit for the individual file size NTFS can support is 16 exabytes, minus 1 kilobyte, of course. So let's dig in a little further. When you're installing an OS, the user chooses a file system. So when formatting an SSD or an HDD, users choose the file system that they're going to use. The process of formatting each type of drive is slightly different, but both are compatible with NTFS. So when an HDD is formatted or initialized, it's divided into partitions. Partitions are those major divisions of the hard drive's physical space. Then within each partition, the OS keeps track of all the files it stores. Each file is stored on the HDD in one or more clusters or disk spaces of a predefined uniform size. Using NTFS, the sizes of the clusters range from 512 bytes to 64 kilobytes. Windows NT provides a recommended default cluster size for each drive size. So, for example, a 4 gigabyte drive has a default cluster size of 4 kilobytes. The clusters are indivisible, so even the smallest file takes up one cluster, and a 4.1 kilobyte file takes up 2 clusters, or 8 kilobytes on a 4 kilobyte cluster system. You follow? See, cluster sizes are determined based on balancing a trade-off between maximizing use of disk space and minimizing the number of disk accesses required to get a file. With NTFS, generally, the larger the drive, the larger the default cluster size, because it's assumed that a system user will prefer to have fewer disk accesses and better performance at the expense of less efficient use of space. So when a file is created using NTFS, a record about that file is created in the master file table, or MFT. The record is used to locate a file's possibly scattered clusters. So NTFS looks for a storage space that will hold all the clusters of the file, but it isn't always able to find one space altogether. Now, along with its data content, each file contains its metadata, which is a description of its attributes. Now, one of the distinguishing characteristics of NTFS compared to FAT is that it allows for file permissions and encryption. Notable features of NTFS are right in here. We've got organizational efficiency. So NTFS uses a B-tree directory scheme to keep track of file clusters. This is significant because it allows for efficient sorting and the organization of files. Accessible data. It stores data about a file's clusters and other data in the MFT, not just an overall governing table like you get with FAT. File size. See, NTFS supports very large files. User permissions, because it also has an access control list that lets a server administrator control who can access specific files. You've also got integrated file compression, and this is going to shrink file sizes and provides more storage space. Unicode file naming, because it supports file names based on Unicode. NTFS has a way more natural file naming convention, and it allows for longer file names with a wider array of characters. Non-Unicode naming conventions sometimes require translation. As far as security goes, NTFS provides security for data on removable as well as non-removable disks. Also requires less storage. It has support for sparse files that replaces empty information, long strings of zeros, with metadata that takes up smaller volume of storage space. Easy volume access. So NTFS uses mounted volumes, and this means that disk volumes can be accessed as normal folders in the file system. All right, let's pit these advantages and disadvantages against each other. Of course, there are several advantages, but it always comes with a disadvantage to using this NTFS. I'll show you some. Some of the advantages include control. One of the primary features of NTFS is the use of disk quotas, which gives organizations more control over storage space. See, administrators can go in there and use disk quotas to limit the amount of storage space any given user can access. Performance. NTFS uses file compression, which shrinks file sizes, increasing file transfer speeds, and giving businesses more storage space to work with. It also supports very large files. Security. So these access control features of NTFS lets administrators place permissions on sensitive data, restricting access to certain users. It also supports encryption. Easy logging. See, the MFT logs and audits files on the drive, so administrators can track files that have been deleted, added, or changed in any way. NTFS is a journaling file system, meaning it logs transactions in a file system journal. Reliability? Yeah. Data and files can quickly be restored in the event of a system failure or error because NTFS maintains the consistency of the file system. It's a fault-tolerant system, and it has an MFT mirror file that the system can reference if the first MFT gets corrupted. So then what are the disadvantages? Do have limited OS compatibility. That's the main disadvantage, in fact, of NTFS. It's limited OS compatibility. It's read-only with non-Windows OSs. Limited device support. So many removable devices don't even support NTFS, including Android smartphones, DVD players, and digital cameras. Some other devices don't support it either, such as media players, smart TVs, and printers, and I'm sure there's more, but you'll understand that. Mac OS support. So OS X devices have limited compatibility with NTFS drives. They actually can read them, but not write to them. Now, Microsoft developed FAT32 before NTFS, making it the oldest of the three file systems. So it's generally considered less efficient than NTFS, as a smaller 4 GB file size and 32 GB volumes in Windows. FAT32 is a lot easier to format than NTFS and simpler in some other ways. Its file allocation table is a less complex way to organize files than the MFT and NTFS. And because it's simpler to use, FAT32 is more compatible with non-Windows OSs, and it's used where NTFS generally isn't, such as smart TVs and digital cameras and those kind of digital peripherals. FAT32 works with every version of Mac, Linux, and Windows, and like we were talking about earlier, NTFS is read-only with both Mac and Linux. So exFAT, it was designed as an evolution of FAT32, so it's going to be the newest of the three file systems. So it retains the positive characteristics of FAT32, lightweight, more flexible file allocation system, while overcoming some of the limitations. For example, FAT32 can only store files up to 4 GB, while exFAT can handle file sizes of 16 exabytes. exFAT does require additional software to work with Mac and Linux systems, but it's more compatible with them than NTFS. It's ideal for when users need a larger file size, and FAT32 can afford, but needs more compatibility than NTFS. The journaling file system in NTFS also makes it possible to use the journal to repair data corruption, something FAT cannot do. The MFT in NTFS holds more information about the files being held in FAT's file allocation tables, making for better file indexing and cluster organization. All right, so there you go. Now you know everything you need to know about New Technology File System, otherwise known as NTFS. I know you got a lot out of it. Take this knowledge forward, my friends, and I'll see you in the next video.